Hi, welcome back from chapter 2. I am Dr. Maya Tunde. So, this is a continuation of the atoms period and periodic table. This is the periodic table part. I'm very interested in periodic table and the elements. I like to see the beauty of the elements. So, the periodic table has all the elements that you can find. It is arranged, the periodic table elements arranged in the increasing of atomic number. So if you see these elements, you see they're in there are, we call the horizontal lines, they call periods. The vertical lines we call groups or families. In 1860, Mendeleev found a periodic table, and he at that time there are like he arranged the elements in on order, and then he found that the elements with a certain property, similar properties recur. So that's what he said. He put the elements with the similar properties into one group or family. So that's what we call in the group or family. They have some similarities, but especially in the main group. Okay, we call it these two lines, and this area are the main group elements. Periodic table has many classifications, but we mainly can classify metals, non-metals, metalloids. If you see the like kind of greenish color is metals. They are metals, and then the orange is for metalloids. Blue is for non-metals. It's surprising for me when I first saw it when I was a kid. Oh my gosh, there are so many metals on Earth than the non-metals and the metalloids. Yes, there are so many metals. Um, so then there are some properties of the each metal, non-metal and metalloids. They have their own properties. And then, so the periodic table has the groups have their own names. Group 1 called alkali metals, So this is group 1, lithium, sodium, potassium, rubidium, cesium, francium. Group 2 we call alkali earth metals, beryllium, magnesium, calcium, strontium, barium, radium. You go to this side, and then this is called chalcogens, oxygen, sulfur, selenium, tellurium, polonium. If you see the chalcogens, you have the metals and also metalloids in the group. And then you see this group, group 7, halogens, fluorine, chlorine, bromine, iodine. And then you see the last group, it's noble gases. So in the exam, I can ask, identify a metal, identify a non-metal, identify a metalloid, identify an alkali metal, identify a noble gas. So you need to know, you get to bring a periodic table to the exam, but it's a blank periodic table, I mean, it's not showing, okay, this is group 1 alkali metals, no, nothing like that. So you need to know by looking at the periodic table, group 1 is alkali metals, group 2 is alkaline earth metals, the group 8, which is the last group, is noble gases, group 7, so like that. So you need to know. And then there's inside we call transition elements, because I told you these two groups are the main groups. And then, so that's about, there are so many other things, but that's what I'm mainly focusing here on the periodic table. And I'm going to my next topic, which is the moles and molar mass. Very important topic. So mole and molar mass, it has calculations. And before going to the calculation, I like to explain you some theory, which is what is a mole. Mole is a number, but think about you get to go to the store and buy eggs. You don't say give me 12 eggs. No, you say dozen of eggs. So it's a 12 is a like a dozen is a number that used for 12. Anything 12 we call dozen. Like that, mole also a number. What is the difference? It's a very big number. How big? 1 mole is 6.022 into 10 to the power 23. In the calculation, I would use 6.0. 6.0.6 in 6.022 into 10 to the power 23. So, so it's a bigger number. So that's what we find it difficult. But if you think about other than chemistry, if you can count 6.022 into 10 to the power 23 eggs, that is 1 mole of eggs. And then if you count 6.022 into pebbles, 1 mole of pebbles. It goes like that. So 1 mole. So how we relate this mole to chemistry? Where the chemistry come in the mole? Any species, if you can, basically the 1 mole is like 12 grams of carbon is 1 mole. Same way, so here, example, if you see, like always, the molar mass is like, you can always, the molar mass is mass of a 1 mole of an element. Example, like, in the periodic table, you see, okay, 12 grams is 1 mole. And again, if you see here, let me see the periodic table. How to get the periodic table back again? Oh yeah, it is. Okay, here's my periodic table. So here I can see, okay, 12 grams is 1 mole. 14.0, if you have nitrogen, 14.01 gram, that is 1 mole of nitrogen. If you have 16 grams of oxygen, that is 1 mole of oxygen. So what if I have 32 grams of oxygen? How many moles? 2 moles. And I'll go back. So 1 mole has how many atoms? 6.022 into 10 to the power 23. So 16 grams has 1 mole, number of oxygen atoms 6.022. 32 grams have 2 moles, number of atoms also multiplied by 2. Okay. So in mole calculation, you always need to think about 2 things. Molar mass come to the middle. Number of moles, and then there another thing is number of atoms. So if I write it like this, let me see. So always, let me see whether I can get an empty sheet here so I can write it. No, I can't do it. Okay, so here you can see, okay, let's take carbon, okay? So I have carbon, which is 12 grams, which is, this is the molar mass, right? You have 1 mole. How many atoms? 6.022 into 10 to the power 23. 1 mole has 20 grams, which is this one. I multiply by 2, go to 2 moles, which is the mass 24 grams. I have 2 into 6.022 into 10 to the power 23. That's the theory. So if you think about 2.5 moles, you multiply 12 grams by 2.5. I have to find my calculator. You can do it with me. 12 into 2.5, which is 30 grams. And then I get 6.022 also into multiply by into. So you multiply this by 2, yeah, it's 2. And then 2.5 into 6.022 into 10 to the power 23. So that's how you do the calculation. So before I go, let me go to the another one. I'm saying, okay, I have 45 grams of carbon. Okay, I'm saying, okay, I have 45 grams of carbon. How many carbon moles I have? My first question. My first question is, how many moles of carbon? Second part, how many carbon atoms? So how many carbon moles? I take the mass, which is 45 gram. I know 1 mole of carbon is 12 grams. So I do the math here. Gram cancel out. 45 divided by 12. I get 3.75 moles. So that is my moles. How many carbon atoms? I know one carbon atom is 3.7. Sorry, one mole is 6.022 into 10 to the power 23. But now I have 3.75. I get it 3.75 multiplied by 6.022 into 10 to the power 23. This type of multiplication, let me check this, 23. This type of multiplication, how I plug into my calculator, I don't plug the 10 to the power 23 to my calculator. How I do it, I just take 3.75 multiply 6.022. I get my answer, which is 22 into 58, 22.58 into 10 to the power 23. I want to write this in the a scientific notation, so I would write 2.2 in 58 into 10 to the power 24. So that is my answer. So that is extra. You have more in the PowerPoint. So let's go back to the PowerPoint. So my question here is, so let's look at the question in the PowerPoint. Calcium is the most abundant metal in the human body. A typical human body contains roughly 30 moles of calcium. Determine the number of carbon atoms in 30 moles. The number of moles in a calcium sample containing this many atoms. So you see you have to go from moles to atoms. So the first one they did 30 moles of calcium. You know 1 mole of calcium has Avogadro's number of atoms. So you multiply number of moles by Avogadro's number, you get the number of atoms. Now they have given you number of atoms in the part 2 asking number of moles. So what you do, you take the number of atoms, divide by Avogadro's number, and you get the number of moles. Okay. So that's the always just the juggling with some numbers, but it's not that hard if you understand the theory. Okay, you have the molar mass, your molar mass, 1 molar mass is so molar mass you have, and then you multiply by the number of moles. You can get the Avogadro multiply by Avogadro's number. You can always get the number of atoms. So I get some questions here. So 25 grams. So you divide by the molar mass like that, and then I want to show you this one. This has a lot of important information. So that's what I show. Okay, you have moles, grams, and atoms. Moles, in order to convert to grams, you multiply by molar mass. Then grams, to convert to the moles, you divide by molar mass. Moles to atoms, multiply by Avogadro's number. Atoms to moles, you divide by the Avogadro's number. So in the question, when you get a question, you need to see what I have to do. I want to convert moles to mass, mass to moles. So then you have to think a little bit. There's a one step ahead always. You can't always just know there's Avogadro's number. You don't need to use in all the mole calculations. So I look at this question, a number of carbon atoms in the 0.515 gram of carbon, determine the number of carbon atoms in the grams of carbon. So you know this is the number of grams. So can you multiply grams by Avogadro's number? No, always. The relationship is between moles and Avogadro's number, but you can convert grams to moles by dividing. So that's what I do here. This is a step 1. This step is converting to moles. So in order to convert to moles, you take the mass, you divide by the molar mass. And then you number of moles, then you multiply by the Avogadro's number. So this is how you get the atoms. And then you go to the next one, the mass of helium atoms. Okay, so this is the number of atoms. You have to find the mass. You get the number of atoms. Divide by the Avogadro's number. You get the how many moles. Once you have the number of moles, you multiply by the Avogadro's number. If I explain you part B again, here you have the atoms. Atoms divide by Avogadro's number. That's what I do in this first step. You get the number of moles. Number of moles, I cannot stop from number of moles because they ask the mass. So we get the number of moles, you multiply by the molar mass of helium. Okay. So that's about in this chapter, converting mass. So you have the moles, multiply by the molar mass, you get the grams, moles. Think about, you have 1 mole of carbon, how many grams? You multiply by 12, right? So 2 moles, you multiply by 12, you get the grams. Grams to moles, you divide. So you divide by the molar mass. It's like that. So this is the end of chapter 2. I hope this video is helpful. Thank you.